Hey everyone, today we are going to tackle an interesting problem involving binary search tree BST. The task is to convert a given BST into a greater sum tree GST. But what does that mean? Let's break it down. We are given the root of a binary search tree and we need to transform it into a greater sum tree. In a greater sum tree, each node value is replaced by the sum of all values greater than or equal to the node value in the original BST. This transformation preserves the properties of the BST but modifies the node value to reflect cumulative sum of greater values. Let's understand the BST and GST. A binary search tree has the following properties. The left subtree of a node contains only node with key less than the node key. The right subtree of a node contains only node with key greater than the node key. Both the left and right subtree must also be BST. In a greater sum tree, each node new value is the sum of the node value and all values greater than it in the original BST. To solve this problem, we can use a reverse in order traversal, which is right node left, to accumulate the sum of node values. This approach ensures that we always handle the greater values before the smaller ones. For this step, first we reverse in order traversal. We traverse the tree starting from the highest rightmost node which has the greater value to the leftmost node. For accumulation, we keep a running total of the sum of node values encountered so far. Third, we update the node value. For each node, we update its value to the running total before moving to the next one. Let's write the code. Okay. Self root tree node sum well integer if not root, then if not root, then return 0. We perform reverse in order traversal. For that, sum of value r equal to root value plus self of DFS where root of right value sum of value. Root value equal to sum of value right plus sum of value. Then we return root value plus self of DFS root dot left value root of value. Then we create another function bst to gst. For that function self of self dot root in tree node. We pass tree node self dot dfs of root and 0. We return root. So first function dfs, the dfs function take two arguments, the current node root and the accumulated sum value. Well, if the node is none, we reach the end of a subtree, we return 0. Then we write subtree processing. We recursively call DFS on the right subtree to process all the nodes with greater values. We then update the current node. We update the current node value by adding the accumulated sum of to the sum of the current node and all greater nodes. When we left the subtree processing, we recursively call DFS on the left subtree with the updated current node value. We then return value. The function returns the new value of the current node plus the sum of all nodes in the left subtree to maintain the running total for parent's node. We then create new function bst to gst. This function initializes the conversation by calling DFS with the root node and an initial sum of 0. Finally, it returns the root of the transform greater sum values. By using a reverse in order traversal, we ensure that each node value is updated with the sum of all greater values efficiently. This approach leverages the properties of BST and transforms them into greater sum trees with the optimal time complexity. Let's run the code. Okay, wrong answer. Let's run the code again. Okay, it accepted. I hope this explanation clarifies how we can convert a BST into a GST. Feel free to leave your question in the comment below. Let's submit the answer. Okay, it complete. It's also challenge accepted and completed. If you enjoyed this video, give it a thumbs up and subscribe for more algorithm explanation. Thank you for watching.